Assalamualaikum and hi everyone. We are from team 1. I'm Fitri.
Hi Matya.
I am Najmi
And I'm Hawa.
and we will explain about introduction of
Communication
Principle.
Hello everybody. I'm the first presenter of my group. In my part, I'll cover three main topics, which is definition of communication principle, process of communication, and the type of system. So let us start up with the definition of communication. It is always a great way to define things so that we can understand what we are dealing with. Communication is a process of sending and receiving messages. If I change this to a stick figure, it will be like this. There is a sender and there is a receiver. The sender generates idea and encodes and transmits as a message signal to the receiver. The receiver decodes the message signal and get the message. Now the receiver can become the sender and can give the feedback to the first person as a way before. So we understand what is communication is, but how does it work? How can we send data or information to someone who is far from us? In communication system, the process of sending information signal from one point to another point involving three important processes, which is transmission, receiving and processing. Figure 1 shows the block diagram of basic communication system, which involve input transducer, communication system and output transducer. ST is the input signal and RT is the output signal. MTX and MRX is the modulating signal. In the second diagram, the communication block explained more in detail. In the input transducer, the input signal is converted into electrical form. At the transmitter, the modulation process occurs. At the transmission medium, it connects the transmitter and receiver, enable the wave to propagate through the medium. At the receiver, it receives the signal and convert to modulating signal called demodulation. And at the output transducer, it convert the modulating signal to original form of signal that is useful to user. Next, we will see on the type of system, which is analog system and digital system. In analog system, signal is processed in analog, takes any value within a range. More sensitive to noise, as noise is harder to distinguish from the desired signal. Whereas in digital system, information signal can be digital or analog signal through analog to digital conversion. It takes limited number of values. In digital system, noise is easier to distinguish as the desired signal can take only specific values. That's all for the introduction part. I've covered the definition of communication system, the process of communication system, and lastly is the type of communication system. Hopefully all of you understand the introduction part.
Next, we're going to talk about signal classification. Number 1 is predict and non-predict. Predict is a repetition wave, while non-predict is a random signal that had appeared. Number 2 is analog and digital. Analog is a continuous wave that in strength and quality, while digital is a direct pulse with either on or off that convert in binary form. Number 3 is a continuous and discrete signal. Continuous is a signal that they are defined all time instant, while discrete define only certain time instant. Number 4 is power and energy signal. Power signal that have finite power and non-zero power, while energy signal have only finite energy. That's all for the classification of signal.
Hello guys and Assalamualaikum. In this video, I want to show you how we generate harmonic signal using MATLAB. So in front of me, I've done the coding for the MATLAB to generate harmonic. The function CLC is for clear, and the FS is the frequency sampling. We set to 10,000. So the time we set 0 to 1 in the interval of 0.1, and the sampling frequency interval of 0.04. So the F equal to 50 means that we generate frequency fundamentally at 50. So for the harmonic, the concept is we multiple the frequency, the fundamental frequency. So what I'm doing here is we multiple the frequency fundamentally, multiple with 1, and third harmonic we multiple with 3, and so on. 5 we multiple to 5, and then we add all the signal to generate harmonic signal. This function plot is to plot the signal that we have created. So we run, and then we can see that harmonic signal is generated. That's all. Thank you. Assalamualaikum and hi everyone. Just now, my friend Mati again has mentioned about communication system that consists of transmitter and receiver through processing. But what's connect both of them?
A few moments later.
Yes, exactly. The transmission medium. There are 3 standard types of transmission. The first is simplex, which means broadcast signal only travel in one direction. For example, radio broadcasting to computer and printer communication. Second is half duplex, which means signal can travel both direction but only one signal at one time. For example, that we commonly use walkie-talkie. If we want to use walkie-talkie, we must push the button to speak and release to hear. This is how walkie-talkie works. And the third and last is full duplex. Full duplex means signal can travel both directions simultaneously. This is example of full duplex.
Hello, Assalamualaikum.
Hello, Hawa. Hello, Hawa. Dengar tak?
Ya.
Kau kat mana?
Ada ni kat bawah ni.
Okay, kita orang on the way.
Okay.
Next, we move on to type of transmission medium. Transmission medium can be categorized into 2 parts, which are the unguided and guided transmission. For the unguided transmission, which is commonly called as wireless transmission, air is the media that enable the electromagnetic energy to flow easily. Next, we will explain about guided transmission medium, or called as wired transmission. I will categorize into 4 different types. The first is twister pair, which has the 2 main types: shielded twister pair and unshielded twister pair. Twister pair cable is consists of 2 conductors that twisted each other to cancel out the electromagnetic interference or noise. Okay, we move on to coaxial cable. Coaxial cable consists of 4 different type of material. The third transmission medium is optical fiber that consists individually by plastic material that protect by the protection tube. For example, long distance telecommunication that use the fiber optic provide high speed data for faster faster transfer. Okay, last is the waveguide, which means structure that guide the wave. For example, electromagnetic wave or sound. Okay, that's all for me. Thank you.
So, now that we are done talking about types of signal and medium, I'm going to explain to you about system efficiency. There are several ways to measure system efficiency. The first one is how close the transmitted signal to the received signal. In real life situation, there are always noise in the received signal. For example, is amplitude wide Gaussian noise. It is where when we transmit an signal with the amplitude of 5, but then the received signal we have the amplitude of 6. So, an efficient system is a system with less noise. Or in another system, we use the term signal to noise ratio. And in digital system, we have the bit error rate. Second is how much power needed for the system to transmit the signal. From our lecture, we have learned that we have 3 types of modulation, which is amplitude modulation, frequency modulation, and phase modulation. And we have learned also that phase modulation have the least power usage for the system. So with less power usage, that means we can save the energy usage for our device, which means our battery will last longer. That means low power usage is a more efficient system. Third is the bandwidth needed for the system to transmit the signal. So bandwidth is a range of frequencies, and it is very important for communication companies because the government only allow them to use a limited range of frequency. So a signal with high bandwidth means the signal contain more information compared to a signal with low bandwidth, which means it have less information. For example, communication company such as Telkom will use signal with low bandwidth so that they can put more user in their limited range of bandwidth. However, for radio station, they will need to use a signal with higher bandwidth because they need to transmit signal for music with high quality. So, in terms of bandwidth, the efficiency of the system depends on its functionality, whether we want more user or higher quality signal.